Hiya, how's it going? Right, in this video I'm going to look at proving some trigonometric results. Okay, so these ones in particular, sine rule, which is that, cosine rule, there it is, an area of a triangle, half AB sine C. Okay, now I would say as a mathematician you really ought to see a proof of these sorts of results. Okay, because you shouldn't be happy with using something unless you know for certain that it works. Okay, you shouldn't just take somebody's word for it. Okay, obviously you should trust your teacher, yeah, but you shouldn't really take their word for it alone. You shouldn't really be 100% satisfied unless you've seen the proof yourself. Either you've read it, watched it, or worked through it. Okay, and that goes for anything, you know, quadratic formula or Pythagoras Theorem. A mathematician needs to know that it actually works before we can actually go ahead and use it. Okay, right. Let's have a look to see how this proof works. Okay, now the method is just draw out a triangle, and then the convention is use lowercase letters A, B, C for the sides, then uppercase letters for the angles opposite those sides. So opposite side A, angle A, opposite side B, angle B, opposite side C, angle C. Okay, and then from those we then just can proceed. And the first step is just to drop a perpendicular from B. Angle B there to the base. Okay, I'm going to call that H for obvious reasons, the height. Okay, and it gives me a right angle triangle that I can use, and I've got a right angle triangle on this side as well. I'm going to use that to prove these results. Now the first thing I'm going to do is look at this angle there, and I'm going to write down the result concerning that, and that is the sine of that angle, sine C, is opposite over hypotenuse. Okay, because we can use standard trigonometric results as right angle triangles to do this, you see. And if I make H the subject, what am I going to get? I'll write it up by here. So H is equal to A sine C. Okay, and I'm going to do the same sort of thing with this, a similar result for this. So the sine of that angle, sine A, is equal to, again, opposite over hypotenuse, H over C. And making H the subject there, we'll get C sine A is equal to H. Okay, can you see what result I'm going to prove first? Okay, bit of a hint, I've used sine in these. Yeah, I'm going to use the sine rule. Okay, I'm going to prove the sine of this one. Now, because H is equal to both of these, that means that these two must be identical. They're exactly the same. Okay, and I'm going to write that down by here. So you've got A sine C is the same as equals C sine A. Okay, you could use the identity symbol, but I'm just using the equals. Okay, because yeah, I don't know what audience I'm going for here. It could be a GC audience, okay, it could be A audience, could be beyond, okay, but I'm using the equals, okay, I'm sure you don't mind. Now the step is just to put all the same letters onto one side, okay. So if I put the sine A onto the left hand side, you'll get A over sine A, and if I put the sine C onto the other side, you get C over sine C, okay, and then there you can see it. I proved this result here. Where does that come into it? Well, a couple of ways of explaining that. One is, I could just decide to reorder the letters on this triangle. Okay, so if I just switch the letters, only switch the letters, mind, of those two around, and hence of those two around, then I'd have got another result, A over sine A equals B over sine B. Okay, or I could just instead have a perpendicular from here to here, so that's going to be perpendicular, or from here to here. Okay, so a couple of ways of doing it, but we will get that generic result. But that's enough to show you that it's going to work. Okay, the whole thing is going to work. So that's that. That's the first one proved. Okay, that is the sine rule. Now next I'm going to prove the area of the triangle formula, because you'll notice that also makes use of the sine ratio, and that's a simple one to do with what I've got already. You know already that another formula for the area of a triangle is a half times the base times the height. Okay, so the base of that is B. Rather convenient, that, isn't it? Yeah, well, I did that on purpose, if I'm honest. And the height there is H, so half BH. Okay. Now the H, I'm just going to replace with. Can you see what I'm going to replace it with? Yeah, I'm going to replace it with that one there. Okay. So that's A sine C. Okay, and just switching the letters around so that they're in alphabetical order, because we prefer some sort of order as a mathematician. Okay, you've got half AB sine C. That's that result there. So that's the sine rule proved. Okay. Notice actually while I'm on it, if instead we'd use that, okay, see what we get. We get area equals a half BH, so half BC sine A. Notice that gives us the formula if we've got those two sides and that angle there in between them. Okay. Traditionally, that is how we remember it, half AB sine C. But the area of the triangle formula works such that if you've got two sides and the angle between, then yeah, that's what you need to work out the area. Okay. Right, that's those two done. Now for the last one, okay? I'm just rubbing this off because this is work I don't need anymore, okay? If you missed it or if you didn't finish copying it up, the genius thing about these videos is that you can just pause, rewind and just watch again, okay? I'm now going to prove this result here, the cosine rule. Now, if it's not been pointed out to you, okay, I'm going to show you now, okay, that this first bit is like Pythagoras Theorem, isn't it? Actually, it is Pythagoras Theorem. C squared equals A squared plus B squared. In a right angled triangle, the angle is 90 degrees and cosine 90 is 0, okay? If you don't trust me, just go ahead and work it out, okay? But it is 0. So that is Pythagoras Theorem, that bit. What that means is, what it implies is, for the proof bit, we've got to use Pythagoras Theorem, okay? So with this right angled triangle here, I'm going to use Pythagoras Theorem. The only thing is, I don't know what that there is as a letter. So I'm going to give it one. And that's what we do in proof. We just assign letters to unknown sides to help us with our working, okay? I'll call it X. Did you hear the loud car? So that right angled triangle I need as well. And this length here must be B minus X. Because if that bit is B, if all that is B, that is X, that is B minus X, isn't it? And so I'm going to use Pythagoras Theorem on both of those. So the first one I'm going to do it for is this one here. So what have I got? I've got A squared is equal to X squared plus H squared. So A squared equals X squared plus H squared. And for this right angled triangle, I've got, that's a terrible number 2, isn't it? So I'm going to rewrite that. A squared is a bit better. B minus X, that's got to be in brackets. If you're squaring all of that, B minus X squared plus H squared is equal to C squared, okay? Now what I'm going to do is I'm going to expand the brackets there. So I've got B squared minus 2, oops, I said 2 but missed it out, 2bx plus X squared plus H squared is equal to C squared. Okay, happy with that? If not, again, just pause the video, rewind and work through it. But it's just simply expanding brackets there, okay? Now, can you notice these bits here? The X squared plus H squared there and there? Yeah, so what we can do is we can replace the X squared plus H squared there with A squared. Okay, because it's exactly the same. So my next line, I'm going to write down B squared minus 2bx, and instead of X squared plus H squared, I'm going to write down plus A squared. Okay, is equal to C squared. And we're nearly there, aren't we? Okay, because we've got the C squared equals A squared plus B squared, C squared, A squared, B squared. We just need to find a way of getting 2ab cos c. We've got 2b, we just need to find a way of getting the a cos c. So what that means is, with the x here, we're going to have to find a way of rewriting that, okay? And we want that to be the same as a cos c, don't we? So I'm going to go back to the triangle, okay? And how am I going to do that? Well, I need cosine c, so I'm going to again use that angle, but I'm going to write down cosine this time of that angle. And that's adjacent over hypotenuse, as we know, so x over a. And then rearranging that, that's going to give me, let's write it up here, x is equal to a cosine c. Okay, so instead of the x there, because I've run out of space at the bottom, I'm just going to replace that with that a cos c. A cos c. And that's it, okay? Because if I rewrite it all in order, I've got the a squared plus b squared, and then this bit is the same as 2ab cos c, which is that there. That's the cosine rule formula proved, okay? Well, I'm hoping you enjoyed that, okay? Hoping that you got something out of it, okay? And thank you for watching. I'll see you again. Okay, right, I don't know why, but this video was an absolute nightmare for me to make, okay? Things just kept on happening or going wrong, or just I made a little error here or there, or I said the wrong thing and I had to re-record it. It was just an absolute nightmare, as I said, okay? So I've done something a little bit unusual. I've put together a selection of bloopers for you to watch, okay? For you to entertain yourselves, okay? Yeah, it's just, I just couldn't believe it. I just couldn't go. It took me ages to do this, okay? But anyway, here you are. Here's a short blooper reel for you, okay? Just for your enjoyment, okay? Hiya, how's it going? Right, today I'm going to look at some trigonometric formulae and Hiya, how's it going? Right, in this video I'm going to look at some trigonometric formulae, more specifically how to prove the sine rule, cosine rule and the area of the formula. Area of the formula. Hi, how are you doing? in this, no, I can't do that. I can't do it. Uppercase. So that's A. That's going to be angle A. That's side B. That's going to be angle B. That's side C. That's not side C. Damn it. Now, taking those two to begin with, you can see that h is equal to that and h is equal to this. You can say that these two expressions are equivalent, okay? You can say that a sine c and c sine a are the same because they're both equal to h, okay? So I'm going to write an implication symbol here. This implies that a sine a is equal to c sine a. And hiya, how's it going? Right, in today's video I'm going to look at proving these results here, okay? So you should probably side C, angle C, okay? And the method is by first of all dropping a perpendicular from B down to the base here, okay? And I'm going to show it's a right angle triangle here. Will you stop buzzing? Light keeps buzzing. Okay, which means swapping those two. Left order is just swapping the labelling around, and then I'd have the A sine over sine A equals B over sine. So this one here, we've got A squared plus X squared is equal to H squared. Yep. A squared. Bloody idiot.